Fabrication of trusses. Cutting the workpiece as per dimension as shown. Welding the metal piece by using arc welding. Inspect the trusses as per dimension as shown. Weld inspection. The complete weld shall be subjected to visual inspection to ensure uniform and correct reinforcement. To ensure that the weld face is free from welding defect like crack, porosity, lack of fusion, slag inclusion, unfilled crater, undercuts, overlap, concavity, etc. Shall we learn in detail about these welding defects? Welding defects. A defect or fault is one which does not allow the finished joint to withstand or carry the required load. Weld defects may be considered under two heads: external defects, internal defects. Let us now study some of the defects in welding. Cracks are one of the important defects which we have to eradicate. The moisture in the weld metal and molten size formation are some of the reasons for the cracks. Lack of penetration is due to the poor fit-up which has no proper gap and due to higher values of electrodes. Incomplete fusion 1 inch not getting fused is again due to the misalignment of the weld joint of the fit-up. So another defect is slag inclusion. The flux due to the narrow root gap. The flux getting entrapped during welding so that it will get into a formation is called slag. Undercutting is due to high electrode diameter. High electrode current, also high electrode speed, will lead the way to material like this. So this is called undercut, which has to be avoided. There are different types of porosity. Porosity is due to oxygen entrapment, moisture entrapment in the weld pool. In the weld pool, when air tries to escape from the bottom pool, it takes a void and becomes a gap fit inside the weld pool, and that is called porosity. Welding certification. As the visual inspector is capable of identifying external surface defects only, non-destructive tests are to be done on the welds in order to certify the quality of the welding.
Dear trainees, so far we have taken you through the basics of shielded metal arc welding, and we hope that the same had been quite interesting and useful to you. By now you are aware that welding is a wonderful career opportunity, and the industry as well the nation is in demand for skilled welders. We have given this opportunity to you today for learning. Seize the opportunity, learn and become professionally qualified welders for your own prosperity and for the greater prosperity of the nation. We wish you all the best.
Now let us explain about various activities involved in fabrication. Marking and cutting different angles and geometrical shape on sheet metal. Marking and cutting. Now we are going to see how a weld test specimen is prepared for welding. Here the welder is holding the steel plate on the work table. First of all, the welder starts his work by marking the dimensions with the scale and chalk piece. Now, once the marking is completed, the welder uses the center punch and indents the dimension points. Now the specimen is ready for oxygen acetylene gas cutting. The welder uses all personal protection equipments such as safety shield, gloves, safety shoes, etc. The workman chooses appropriate size of the nozzle for the cutting torch, and the cylinder valves are opened slowly using the key, and he tests the gas flow, also cleans the nozzle for free flow of gas. The oxygen acetylene hoses are connected to the cylinder at one end and to the cutting torch to the other end. Now he opens the oxygen and acetylene control valve in the ratio 1:3 and oxidizing flame is produced. The gas flow is regulated for gas cutting. Now, the flame adjustment is completed and cutting is commenced on the job, and welder holds the torch steadily and cuts in a straight line. Similarly, the positions at the work pieces are changed and the remaining sides of the pieces are cut. Now, the cut pieces are held in the vise and edges of the specimen are ground square using a grinding machine. The perpendicularity of specimen is checked using tri-square for the orientation of the joints. Now the plate is ready for the fit-up. Draw a circle, pentagon and an equilateral triangle as per dimensions given in the job drawing using geometrical construction principle or method, keeping O as the center for all these shapes. Construct a circle inside a square. Set the compass for 60 mm radius using a steel rule. Keep one of the pointed end of the wing compass at the punch mark on the square sheet. Draw a half circle clockwise from left to right using thumb pressure. Mark the rest of the circle anti-clockwise from left to right. Mark clearly at the first stroke itself. Construct a triangle inside a circle. Draw the radius of circle as 0.58 into the side of the equilateral triangle. That is 0.58 into 75 is equal to 43.5 mm. Draw the circle with the above radius and mark the center lines JK and ZN. Draw an arc XOY from point N, taking NO as radius and cutting the circumference of the circle at X and Y. Join XY. Joint YZ. And ZX. Construct a pentagon inside a circle. Draw a circle with O as center by using a wing compass. Name the horizontal center as AB, that is, the diameter of the circle. From C as center, CO as radius, draw an arc cutting the circle and name it G. Join points C and G. Now the line CG is one of the sides of the pentagon. Let us see the different positions involved in true welding. Flat position, horizontal position, vertical position, overhead position. Flat position. In flat position, welding object is below the welder and welding electrode is placed downwards while welding. Horizontal position. Now, in horizontal position, welding object is placed in the plane parallel to the welder and welding is carried on x-axis from left to right or vice versa. Vertical position. Vertical position in which the welding object is placed in the plane parallel to the welder and welding is done in y-axis, that is, from bottom to top. Overhead position. In overhead position, as the name indicates, welding object is placed over the head of the welder and in reverse to flat welding, electrode is placed vertically upwards during welding.
Here we shall study shielded metal arc welding, which is the most versatile and commonly used process in the fabrication industry. Now, what is shielded metal arc welding? It is having a shielding with the help of a flux coating. That is why it is called shielded metal arc welding. It is an arc welding where an arc has to be created for heating the material, for which the welder will have to take the electrode close to the job and he has to withdraw by a mm or so. In the process, the arc is initiated. The flux acts as the shield, thus not allowing the atmospheric air to contaminate the weld pool, and hence the name shielded metal arc welding.
There are 4 types of joints used in fabrication welding: lap joint, T-joint, corner joint, butt joint. Lap joints. In lap joints, one plate is placed parallel over the other plate with a lapping length as per requirements. T-joints. In T-joints, one plate is placed perpendicularly over the other plate lead to form a T-type of joint. Corner joints. In corner joints, one plate is placed perpendicular or at an angle to other plate with inside corner edges of plates are placed together. Butt joints. In butt joints, one plate is placed adjacent to the other plate with a small gap in between called root gap. Welding certification. As the visual inspector is capable of identifying external surface defects only, non-destructive tests are to be done on the welds in order to certify the quality of the welding. Shall we learn in detail about these welding defects? Welding defects. A defect or fault is one which does not allow the finished joint to withstand or carry the required load. Weld defects may be considered under 2 heads: external defects, internal defects. Let us now study some of the defects in welding. Cracks are one of the important defects which we have to eradicate. The moisture in the weld metal and molten size formation are some of the reasons for the cracks. Lack of penetration is due to the poor fit-up, which has no proper gap, and due to higher values of electrodes. Incomplete fusion 1 inch not getting fused is again due to the misalignment of the weld joint of the fit-up. So another defect is slag inclusion. The flux due to the narrow root gap. The flux getting entrapped during welding so that it will get into a formation is called slag. Undercutting is due to high electrode diameter. High electrode current, also high electrode speed, will lead the way to material like this. So this is called undercut, which has to be avoided. There are different types of porosity. Porosity is due to oxygen entrapment, moisture entrapment in the weld pool. In the weld pool, when air tries to escape from the bottom pool, it takes a void and becomes a gap fit inside the weld pool, and that is called porosity. metal that are used to melt and join the ends of the base metal. Shall we know them? The three types of electrodes used in metal arc welding are cellulosic, rutile, basic. Let us know more about the types of electrodes, their uses, and where they are applied. Cellulosic electrode coatings are made up of materials containing cellulose, such as wood pulp and flour. The coating on these electrodes is very thin, and the slag is easily removed from deposited welds. The coating produces high levels of hydrogen and is therefore not suitable for high-strength steels. Rutile electrodes are general-purpose electrodes having coatings based on titanium dioxide. These electrodes are widely used in the fabrication industry as they produce acceptable weld shape and the slag on deposited welds is easily removed. Strength of deposited welds is acceptable for most low-carbon steels, and the majority of the electrodes in this group are suitable for use in all positions. Basic or hydrogen-controlled electrode coatings are based on calcium fluoride or calcium carbonate. This type of electrode is suitable for welding high-strength steels without weld cracks, and the coatings have to be dried. Electrodes, especially low hydrogen electrodes, need to be baked in equipment named as electrode baking oven. Electrodes are placed in trays and heated to 300 degrees centigrade for 2 hours to prevent or remove moisture entrapment in electrodes. After baking is completed, these electrodes are transferred to holding ovens which are maintained at a temperature of 150 degrees centigrade and used for welding at this temperature. Plate fillet weld position. Now let us study the welder's qualifications. This is very important because unlike other trades, here the welder has to be qualified enough according to the international standards. The basic requirement for the welder is to start with a fillet weld qualification. This 4 position, that is 1F, 2F, 3F, 4F, is the most easiest and the most simplest of all to start welding. Now, in 45-degree tilt, the welder is going to weld in downhand position. Now, next position is called 2F. 2F is called horizontal position welding. Now, the weld axis is horizontal and electrode axis also horizontal position, and we are going to weld the joint like a fillet weld. So, this will be called 2F horizontal position fillet welding. Now, the third position is called vertical up. Now this is a vertical joint where the electrode is kept at the bottom of the test piece and the welder is going to drag this vertical straight up by welding against the gravity. So this is called 3F position. 4F overhead position. In most of the project, the welder may weld something above and weld metal come against the gravity. The electrode is kept over the head like this, and the welder tries to do this electrode manipulation. This is called 4F welding. Let us know the main tools and accessories used in fabrication welding. They are the bench vise, welding cable, earthing cable, welding holder, welding helmet, welding regulator, chipping hammer, chisel, wire brush, hacksaw blade, hand gloves, grinding or cutting machines, grinding or cutting wheels, leg guard. This is bench vise, which is commonly used in workshops. Vises are used for holding work pieces. They are available in different types. A bench vise is made of cast iron or cast steel. It is used to hold work while preparing the edges of sheets plates and pipes by chiseling, hacksawing and filing. The welding cable's end is always connected to the welding holder. This holder is used to hold the electrode in its jaws. It is made up of copper or copper alloys which have very high electrical conductivity. Now, in order to feed the electrode, a holder is a must. A major portion of the holder is made up of wood. This wood is an insulating material. If there is any electric leakage, it may save the welder from electrical shock. Earth cable is another important cable. It is an important connection for welding. This is an important equipment connected to the welding machine. This is called welding regulator. The welder has got graduations from 60 amperes, 80 amperes, 100 amperes and so on. During the course of welding, the regulator is used to control both the current and voltage. This regulator is important to do the different positions of welding. Welder helmet is a safety and a protective equipment used by the welder during welding. This has two components, the white glass and black glass. A white glass is basically used to protect the black glass from spatters during the welding. And the black glass prevents the ultraviolet rays that emit during welding and protects the eyes of the welder from being injured. This is a GQ4 grinding machine. We use this machine to remove the slag that is coming from welding. We have to remove the slag continuously. For this purpose, we use a 4-inch grinding wheel. AG5 machine is used for cutting. Cutting wheel machine is a heavy-duty machine. We use this machine for cutting mostly very high abrasive tools. These are all some of the wheels and discs that we use in this machine. So, this is a typical grinding tool. The grinding wheels are made up of abrasives. This is a cut-off wheel used and grinding wheel for cutting purpose. This is a grinding wheel and both are 7-inch in diameter. The selection of the equipment depends on what you want to cut. Depending on the thickness, the RPM, the power in watts and so on, you can save time while cutting the huge amount of metal using the appropriate equipment. This is a grinder helmet used for protecting the eyes of wheels. A grinder will always use this helmet so that the metal particles do not get into the welder's eyes. The chisel is used for chipping operation for removing excess metal. Chipping hammer is used for removing the patters and also to clean the interpasses of the welded layer. This is a metallic brush. We have to clean the weld bead with this wire metallic brush. It cleans the welded surface from layer to layer.
Straight cutting on MS plate 10 mm. In flat position. Marking. Before marking, you refer the sketch for outside dimensions of the plate. Here, the size of the plate is with the thickness of 10 mm. The length is of 200 mm and the width 100 mm. Locate the centers of major axis. Now, draw the center line of the major axis. Let us now bisect the center line. Punch the center point. Take suitable radius in the wing compass or a divider and mark 2 points on either sides of the center point. Punch the 2 points. Now, bisect the center line. With the scale and scriber, mark the minor axis. Refer the drawing for marking the line of cut. A rectangle slot of size 160 mm by 60 mm. Keeping a cutting allowance as 1 mm, we need to mark the slot to a size of 158 mm by 58 mm. Take a radius of 29 mm, that is, of the width of the slot, and mark the arcs on either side of the center line from both the ends. By connecting the arcs, you will get the width of the slot. Now you mark the length of the slot as 158 mm using the same procedure followed for marking the width of the slot. Take a radius of 79 mm and mark on either side of the center line to locate the length of the slot. Before punching, refer the sketch and confirm the markings. Hold the punch at 60 degrees. Locate the marking and then keep it perpendicular to plate and proceed for punching. If it is an open slot, we can always start cutting from one end of the plate and follow the marking. But if the slot or the hole is in the middle of the plate, we have to start cutting by piercing the plate. For beginners, piercing may be difficult. Hence, we can drill a hole in the scrap area at one end and proceed for cutting. Always set the job on the cutting table so that the parting piece is free to fall. Gas cutting. As the plate thickness is of 10 mm, adjust the oxygen regulator knob to set the pressure gauge reading as 1.5 bar. Similarly, set the acetylene pressure to 0.3 bar. Select the nozzle size of 1.2 mm and mount it on the blowtorch. In cutting operations, the stream of cutting oxygen sometimes blows the slag and molten metal into the tip orifices of the nozzle, which partially clogs them. This requires cleaning thoroughly. As the plate is of mild carbon steel, you adjust the preheating flames to neutral. Hold the with the inner cones of the preheating flames 5 mm above the end of the line to be cut. Hold the torch in this position until the spot becomes bright red. Open the cutting oxygen valve slowly and steadily by pressing down the cutting valve lever. If it is started correctly, a shower of sparks will fall on the opposite side of the work, indicating that the flame has pierced the metal. After cutting, the nozzle gets heated up, and it is always safe to dip in the water before beginning the next exercise. The quality of an oxy gasket is judged by a few characteristics. A satisfactory oxy gasket shows almost smooth sides. A grooved or a rough surface is a sign of a poor cutting quality. The top edges resulting from the oxy gasket should be sharp and square. Rounded top edges are not considered a good cut. This may be due to improper preheating procedures or not moving the torch in the right speed. An oxy gasket is not considered good when the slag adheres too tightly onto the metal and is difficult to remove. The nozzle conditions and the right sizes also contribute for a good quality oxy gas cut. I hope you have now understood the process of gasketing. You can now practice them safely under supervision till you achieve the required result. In case if you are not sure or confident, please do not proceed, but consult your instructor for help. Thank you. Exercise 3.01 Part 2. Straight cutting on MS plate. Position flat. Marking. Before marking, you refer the sketch for outside dimensions of plate. Unlike the previous exercise, draw the center lines of major and minor axis. Since gas cutting is done in a pre-machined plates, we need to take center lines as reference for all the markings. Now mark the dovetail as shown in the sketch. From the center line, draw a parallel line 21 mm apart. Then mark a dovetail of a minimum width of 51 mm. Mark the width of 102 mm. With the scale and scriber, scribe the lines of the dovetail. Now, with the protractor, mark a V of included angle 60 degrees. In the first step, take 30 degrees in the protractor as shown here and mark 30 degrees from reference surface. Similarly, another 30 degrees from the other. Now, the included angle of bevel is equal to 60 degrees. Punch the lines for cutting reference. For setting of pressure gauges, you can follow the same procedure that we have learnt in earlier lessons. Always maintain a distance of 5 mm between the tip of the nozzle and the workpiece. After cutting is completed, chip off the slack and clean the workpiece. Exercise 3.02. Circular cutting on MS plate. Position flat. Unlike 3.01, you mark the center lines of the plate. Here the size of the plate is same as in the exercise 3.01. 10 mm thickness, 200 mm in length and 100 mm in width. Draw the center line of the major axis. Let us bisect the center lines. Locate the center point of the center line. Punch the center point. Take suitable radius in the divider and mark 2 points in the 2 sides of the center point. Punch those 2 points. Now by using the divider, bisect the center line. Punch the reference points of the center lines. Refer the drawing for marking the line of cutting. In this exercise, we need to make a hole of diameter 75 mm at the center and 4 holes of diameter 30 mm. Keeping cutting allowance as 1 mm, for a 10 mm thick plate, we need to mark the center hole to a diameter of 73 mm and 4 holes to a diameter of 28 mm. The 75 mm hole is to be marked in the center of the plate. Pitch of 4 holes ought to be marked apart 150 mm and 50 mm with equidistance from center lines. Punch the center lines. Draw all 4 circles, one after another. Check all circles with reference to the sketch. Now punch all the circles, one after the other. As the plate thickness is of 10 mm, adjust the oxygen regulator knob to set the pressure gauge reading as 1.5 bar. Similarly, set the acetylene pressure to 0.3 bar. Select the nozzle of size 1.2 mm and mount it on the blowtorch. As the plate is of mild carbon steel, you adjust the preheating flames to neutral. Hold the torch perpendicular to the work. Observe a drill in each of the hole for the start of the cut. Exercise 3.03. Profile cutting on MS plate. Position flat. Marking. Before marking, you refer the sketch for outside dimensions of plate. Here the plate size is 150 mm by 150 mm. Follow the same procedure to locate the major and minor axis. Now we need to mark a bevel at the corners in the size of 25 mm by 25 mm. Once it is done, check your marking. Now mark the profile of semicircle radius of 29 mm. To locate the center point of circles, take another plate of the same thickness and join together for locating the center. Draw all 4 semicircles on all sides, one after the other. After cutting, chip off the workpiece for slag removal. Exercise 3.04. Profile cutting on MS plate 16 mm, position flat. Marking. Before marking, you refer the sketch for outside dimensions of plate. Here, the size of the square plate is of thickness 16 mm and size of 150 mm by 150 mm. Check the plate for the given dimensions in the sketch. Locate the axis of the plate similar to the previous exercise. Draw the center line of the axis. Bisect the center line now. Punch the center point. Take suitable radius in the divider and mark 2 points on the two sides of the center point. Punch the 2 points. Bisect the center line, marking the second center line. 2. Punch the reference points on the center lines. Refer the drawing for marking the line of cutting. Here, we need to make a right angle slot of length 110 mm and width 25 mm. Also, a circular hole of diameter 30 mm is to be made. Moreover, all the four corners are to be made with a radius of 25 mm. Keeping cutting elements as 1.5 mm for a 16 mm thick plate, we need to mark the right angle slot to a size of 107 mm by 22 mm. Circular hole of radius 27 mm and corner radius of 23.5 mm. Now, we need to mark the width for the right angle slot. Then, locate the center line of the slot. Draw the curvature at both the ends of the slot, keeping off the width of the slot as the radius. Mark a hole of 27 mm from the center lines at a distance of 42.5 mm. Locate the center point to draw the arc at the four corners for the radius. Check the marking as per the sketch before punching. As the plate thickness is of 16 mm, set the oxygen pressure as 2 bar and the acetylene pressure as 0.3 bar. Mounted on the blowtorch. Follow all the procedures you have learnt in earlier exercises while cutting.
નમસ્કાર. પ્રધાનમંત્રી કિસાન માનધન યોજના અંતર્ગત નાના અને સીમાંત ખેડૂતો માટે ભારત સરકારના કૃષિ એવં કિસાન કલ્યાણ મંત્રાલય દ્વારા આ યોજનાની શરૂઆત કરવામાં આવી છે. આ યોજનાની વિસ્તૃત માહિતી CSCના બનાસકાંઠાના ડિસ્ટ્રિક્ટ મેનેજર શ્રી સંજય પ્રજાપતિ અને ખેડા